Hello everyone, welcome to this video on recursion in Python. In this video, we will cover the basic principles of recursion in Python and we'll get a little bit into memory management in Python. So this understanding of memory management is required to fully understand how recursion works in Python. So let us get into the definition of Python. So what is recursion? So the definition you're seeing here on the screen is from Wikipedia. So it says a function or a method can be called recursive if it has these two properties. One, it should have a simple base case and a recursive step. A simple base case is a terminating scenario that does not use recursion to produce an answer. That means this simple base case should be outside the recursive step that is used to exit out of the loop. If you don't have a base case, the recursion will be in an infinite loop. And a recursive step is the actual call that is made to the function itself. So the definition below that in white, that is a slightly informal definition of recursion. It loosely translates to recursion is a function that calls itself. So let us start a little code on what recursion is using factorial. So for those of you who are not aware of what a factorial is the product of all positive integers less than or equal to n. So n factorial is the sum of all the numbers which are less than or equal to n till 1. To denote it, we use an exclamation mark. So n factorial is denoted by n and exclamation, and an n factorial is a sum of all positive integers less than or equal to n. So that means n into n minus 1 into n minus 2 until you reach 1. Another way we can write this is n factorial is n into n minus 1 factorial, because what you see here is n minus 1 factorial because it is the product of numbers from n minus 1 to 1. This is what a factorial's definition is. For example, if you take a factorial of 4 factorial is 4 into 3 into 2 into 1, so that is equal to 24. Now in the previous definition we have defined two properties that are required for a function to be recursive. So one is a base case and other is a recursive call. So one base case is 1 factorial is equal to 1. So if you replace 1 factorial in this series, so 1 factorial is, if you start here, that is the end. So n factorial, so 1 factorial is 1. Now there is one more base case where 0 factorial is also 1. If you are curious as to how 0 factorial is 1, if you take the equation in line number 2, n factorial is equal to n into n minus 1 factorial, means n minus 1 factorial is equal to n factorial divided by n. If n is equal to 0, that becomes 1 minus 1 factorial is equal to 1 factorial by 1. That means 0 factorial is equal to 1. So that is how we define the base case. The recursive call is this: n factorial is equal to n into n minus 1 factorial. So the base case is 1 factorial is equal to 1, 0 factorial is equal to 1. And recursive call is n factorial is equal to n into n minus 1 factorial. So let us define a recursive function called factorial here. It will take one argument n, and we are defining the base case first. So the base case should be outside the recursive call. The base case is if n is equal to 1 or n is equal to 0, will return 1. Recursive call. The recursive call is n into n minus 1 factorial. Will return n into n minus 1 factorial. So this is pretty much how a recursive call looks like. If we call factorial 4 and print it, we should get 24. It looks like magic, but it is not. So we'll see how this result is calculated in the next section. We need to understand how memory is allocated when a Python program runs before we can fully understand recursion. So when Python interprets your code, it puts objects or functions in memory based on some rules. So it will either place them in a heap or a stack. So here are a few properties of heap and stack. Heap is where objects and variables are stored, so which are not inside the scope of a function. And even if an object is in the scope of a function, it will be referred in heap. So if the reference is done, then that object will be removed from the heap. And usually the heap is relatively slower compared to stack. So stack is where functions and corresponding variables are stored. Whenever a function call is made, stack frame is located in memory. That stack frame will be removed when the function is returned. Stacks are relatively faster. Let us see how our code is handled by Python. So this is the function we have defined previously. We have the base case, we have the recursive call here. So whenever I call factorial 4, this particular function will be placed on the stack at the bottom. When we call 4 factorial, it will return n into n minus 1, that is 4 into factorial 3. Again, here we are calling factorial 3. So when I call factorial 3, one more function call will be placed above the previous function call in the stack. And here again, we are calling factorial 2, that will be placed above factorial 3. We'll be calling this until we reach the base case. Here the base case is factorial 1. So once we hit this in this base case, this will be returned. That will be 1, and as soon as it's returned, the frame will be removed from the stack. The factorial 1 will be returned to the previous function in the stack. Once it is done, it will be removed, and that will be returned back to factorial 2, back to factorial 4, which is 24. So that is how Python handles memory, or rather functions inside memory. So there are better ways to handle this. For example, if there are n number of calls that needs to be made, the stack memory is limited, and if there are a lot of frames that go on top of each other, and when it reaches the limit, it causes stack overflow. There are ways we can reduce the risk of hitting stack overflow, optimizing our function call or function definitions so that we don't use so much of stack memory. So we'll see how it works in the next video. See you in the next one.